We've started off focusing on physical features, moved to biology. Now we're going to move to social sciences, economics, and the intersection between people and people as predators and the ocean. Dr. Christopher Costello, on the faculty at University of California at Santa Barbara at the Bren School for Environmental Science and Management, is an economist, natural resource economist by training, and he has been working for a number of years now on a variety of very interesting problems in the ocean, dealing with decisions that people make about use of the ocean, use of natural resources. Chris approaches problems like this from a very multidisciplinary perspective, combining microeconomics with modeling, empirical analysis to address changes and challenges in fishery management among a number of different topics. His research collaborations, the research topics that he works on, are quite varied, nicely complementary. He's going to share with us some new results today, some things that are just hot off the press. Chris received his PhD from University of California at Berkeley in agricultural and resource economics. And as I mentioned, he's now a professor in environmental and resource economics at UC Santa Barbara. He also holds a position as research associate with the National Bureau of Economic Research. Chris has, I hope, will be also focusing on a paper that just came out in PNAS on some very interesting new global analyses. So without further ado, please join me in welcoming Dr. Christopher Costello.
Hey, Jane. Thank you so much, Dr. Lubchenco. You may be the science envoy to the ocean, but I have science envy after seeing all the great, beautiful images that my previous colleagues have shown. I'm just an economist, so I have a blank slide up front here. I will conclude with one photo at the end, so try to stay awake for that. But what I would like to discuss with you today is really the link between the state of the ocean and the state of the ocean economy. So how does the state of the ocean drive the ocean economy? That's really what I want to get at. And I want to think of that in terms of global fishery prospects. So what are the future prospects for the oceans in terms of fisheries performance for livelihoods of people, for food, and for ocean conservation? I'd like to talk about different management regimes and how they might influence the answer to that question, and also the effects of climate change, and give some, I think, tempting and interesting new results on climate change that have not yet been published. All of the work I will show is collaborative with other colleagues from a number of different disciplines, and they're listed on this bottom of this slide here. Okay, I'd like to try to do four things in the next 19 or so minutes. I'd like to give you some new evidence on the current status and trends in global fisheries. I'd like to talk about the timing to recovery of global fisheries. If we were to implement management reforms that we keep reading about in the New York Times, and if we actually went and did that, I want to tell you what that would mean and how quickly fisheries could recover. You know, is it going to take 10 years or 100 years to get fisheries back in order? What are the prospects for that recovery in terms of food provision on the planet? Can we increase food provision from the oceans if we were to manage our fisheries better? If so, by how much? What are the prospects for livelihoods of the millions of people who depend on fish for livelihoods or for food? And ultimately, what are the effects on conservation? So how many more fish will we have underwater if we were to manage fisheries appropriately? And finally, I'm going to conclude with some new evidence on climate change, and I want to focus on the issue of fishery management adaptation to climate change. How big of a dent can we make in the climate change problem in fisheries if we adapt appropriately? This is just an image of the global wild fish production from the world's fisheries over time. And you'll see that over the last couple of decades, it has more or less flattened out. And this has led to a lot of speculation about why this could be the case. Have we reached a maximum and we're optimally managing world fisheries? Are we continuing to overfish and we're artificially keeping those catches high? There are lots of possible explanations for this, and I want to dig into this. And the way I'd like to do that in this short talk is to start with a little bit of theory. I'm not going to show you a whole bunch of equations. I'm going to show you a couple of very simple graphs that I think tell the story of why I believe and my colleagues believe that there might be a triple bottom line in fishery recovery, that we could increase on all the dimensions that I mentioned earlier and still have that sort of within the scientific limits of the ocean. So here's that basic theory. Most of you have seen a figure like this. I've got the fish stock on the x-axis, and I've got a level of sustainable food, and equivalently the growth rate of the fish stock on the y-axis. It's hump-shaped because if you don't fish at all, you have a very large fish stock, but you're not getting any sustainable food. And if you fish too much, well, you drive the stock extinct or to a very low level, and you're also not getting a lot of sustainable food. So almost very, very simply, that argument suggests this thing must be hump-shaped to some degree. Okay, that's all fine. And if you ask, well, where were we in, let's say, 1800? We were somewhere like that blue dot. If you fish a little bit, you can get some food out of the system, and you still have a lot of fish underwater. And you can fish harder and get even more food because you drive the stock to that point where it's producing a very high level on a sustainable basis. But it's very easy to cross to the other side of that hump and overfish a fishery. This is extreme overfishing, in which case you have a very small fish stock in the water, but it's also producing very little food. If you add in a little bit of economics, I'm going to interpret that hump-shaped curve as the revenue from fishing, and I'm going to interpret the blue curve as the cost of fishing. The reason the costs go up as the fish stock goes down is that fish are harder to find when there are fewer of them, along the lines of Kelly's talk earlier. You could think of fishermen as the predators in this case. So suppose you want to maximize livelihoods of fishermen, and I'm going to think about that as maximizing the distance between the black line and the blue line. Well, that's done at a place like this. You want a fairly high fish stock in the water, and you get a pretty high level of profit or livelihood. That's the green bar that I've shown on the graph. But what if you overfish and you're down at this red dot now? Well, you get less food from that system than you would have had you been at the green dot, or the green bar. You get fewer fish underwater, and you get fewer profits or lower livelihoods for people. So this is the sense in which if we could move from that red line over to the green line, we could get benefits along all three of these dimensions. Of course, there are lots and lots of challenges in how to do that and the timing of doing that, and that's what I'll address for the next few minutes. I want to talk specifically about one thing that can be done once you get to that green bar, and that is a set of institutional reforms. Dr. Lubchenco mentioned earlier that we can look around the world for successes, for different countries and even communities that have tried different things and been successful, and we can extract lessons learned from those systems. And one of the things we've learned in doing that on kind of the social science front is that there are new institutions that can be adopted in the management of fisheries that can raise profits, let's say through increasing prices, through, let's say, higher quality fish, for example, and decreasing costs, often through eliminating what we call the race to fish. So these are just different ways of managing the resource, even if the underlying stock is the same, that could improve people's livelihoods. I'll come back to that in a minute in a much more concrete way. So we want to depart from this very simplistic, static view of the world that I've shown in the figures and look at a much more sophisticated global model of fishery reform. So what we're going to do is gather what we think of as the largest data set of its kind on a stock-by-stock basis, almost 5,000 fisheries worldwide that account for most of the global fish production. We're going to, for each of those stocks, pull out economic data, ecological data, and develop dynamic versions of the model I just showed. And what we're going to do is try to estimate where those fisheries stand today and where they would likely be in the future under a number of different scenarios. I'll focus on 3 here, so keep these in mind. A business as usual scenario, nothing like that has ever been done using data like this. A scenario I call FMSY, that is the fishing pressure that would maximize sustainable yield, maximize food from the fishery. and something I'll call rights-based fishery management, which are these institutional reforms I alluded to earlier. And for each of those, I'd like to look at the effects on food over time, the effects on fishery profits or livelihoods, and the effects on conservation. And ultimately, I'm going to come back and say, well, how does climate change alter the conclusions of this analysis? Okay. So the first piece of data I'd like to show you has to do with the difference between what we're going to call data-rich ecosystems and data-poor ecosystems. Believe it or not, for about 95% of fisheries around the world, we don't know how many fish are underwater. We just don't have a sense of how many fish there are. We know how many fish are caught, but we don't know how many fish there are. If you don't know how many fish there are, it's sort of hard to prioritize reforms, design new interventions, and design policy. So a team of us set out a couple of years ago to develop a whole series of new methods using existing data in these data-poor settings to try to assess the unassessed fisheries. And we found something quite striking, and that is the ecosystems that had a lot of these assessments that were very data-rich and had been using those data tended to manage their fisheries much better. Those fisheries tended to be in much better shape than the fisheries that were data-poor. And that will come back later because it's an important piece of this overall story. So if you take those new methods and you apply them to the 5,000 or so fisheries I mentioned earlier, you can get the first global snapshot of where things stand today. So this is the paper that Dr. Lubchenco mentioned. What I've got here is on the horizontal axis a measure of the biomass of fish. This is all relative to a management target of 1. So you can look at, even a large anchovy fishery compared to a small snapper fishery on the same figure. And on the vertical axis, I'm looking at the fishing pressure that's currently being experienced in that fishery. The color of the dot just refers to the database it comes from, and the size of the dot indicates the size of the fishery. And so, for example, fisheries up in this upper left are of grave concern because they've already been fished below the management target, so their biomass is quite low, and their fishing pressure continues to be quite high. These fisheries are of much less concern. This happens to be the global median, which is in that bad quadrant I mentioned earlier. I'm going to call out 3 of these quadrants as the conservation concern quadrants, and I'll tell you a little bit more about those particular stocks in a minute. But the reason we think of these as conservation concern is because they either have biomass that's below the target or fishing pressure that's above the target. Okay, so what is the timing of global fisheries under these alternative management reforms? So think of this as the business as usual graph, and then the graph that allows us to say, well, if we were to intervene along the lines of what I've been talking about, what kind of recovery might we expect over time? So the BAU scenario, much like climate projections, depends on a lot of assumptions, and we've kind of bracketed that with 2 different BAU scenarios. One of them only applies business as usual to those conservation concern stocks, and the lower one, the much worse one, applies it to all stocks. So under that scenario, you would assume that even those healthy stocks today could become worse in the future. So those are those 2 scenarios, and they both show a continued decline of global fisheries. I should have said this axis measures the percentage of global stocks above a biological threshold. Okay? But the really striking thing here is that we can turn these fisheries around through either this fishing to maximize sustainable yield approach or this rights-based, this institutional reform approach, rights-based fishery management. Those both recover global fisheries. One does, the RBFM scenario does it much more quickly than the other, and that's because it takes much more aggressive current action to restore those fish stocks. Under that scenario, we found that the average time to recovery is about 10 years. You can take those results and disaggregate them across all the major fishing countries of the world, and I've plotted the top 10 here. The left-hand figure shows the change in biomass against the change in profit for that country, for all the fisheries in that country, between the rights-based fishery management and the business as usual scenario. You see here that China is an enormous outlier. China is by far, according to these estimates, the country with the largest to gain from fishery management reforms. And this is because their fisheries are absolutely enormous, and many of them have not been well managed in the past. All of these countries that look like they're all about the same and they sort of seem small on this scale, I've just changed the scale here and blown those countries up, and you see that most of those are Southeast Asian countries that in fact also have huge gains left on the table, sort of to the tune of $2, $3, or $4 billion per year, and major increases in conservation as well. What if you look globally at all of these scenarios? Where are we today with global fisheries? Where could we be in the future with global fisheries? And these are data that have just now been published, but until now there really weren't estimates of these things. So this is where we estimate things are today, sort of on the order of $40 billion a year in profit. You can see the biomass figure here. The size of the bubble and the number refer to the amount of harvest we're getting out of that fishery. If we only apply the new approaches to the conservation concern stocks, so that's about 3/4 of the stocks in the world, you see, pretty reasonable increases in both profit and conservation, and some very, slight increases in harvest. But if you apply those policies to all fisheries in the world, you see a really dramatic story starting to unfold. The first part of that story is that if we don't do anything, and you believe that scenario, things could get a lot worse. The second part is that there's a big, huge gain to be had between where we could go and where we think it's possible to go. And these are all based on data that we've collected from fisheries that have actually done this, so we aren't sort of making up what the possible potential is here. So while it's sort of nice to have new estimates of where things are and where we could go, we think this research raises as many questions as it answers. So I thought I'd talk just quickly about some of the new frontiers. The first big one has to do with climate change. We know that there are going to be big changes, and already are some big changes in productivity around the world's fisheries, in range shifts, in dispersal, in regime shifts. All of these could affect the kinds of results I mentioned earlier. And we can start thinking about how might we climate-proof the institutions that govern fisheries. So we're not so much interested in asking what are the effects of climate change on fish. We're asking how can we change institutions to be robust to the kinds of climate change effects that we anticipate coming. There are also interesting issues regarding ecosystems and food webs. We've heard a little bit about that earlier, and we're pursuing that, although I won't have time to discuss that today. And finally, the whole institutional design. Dr. McKay asked an interesting question earlier, and I'm sure that she and others have interest in this. Again, I won't have a lot of time to talk about that, but perhaps in the Q&A we can get to that. So let me give just a few quick final comments on climate change. What we've done, and this is work in progress, and I honestly debated should I even show these results, but I think these preliminary results are so exciting I thought I would let the cat out of the bag and get some feedback from you. So what we've done here is we've taken 700 of the species that account most for global fish catch, and we've partnered with Ben Halpern and some of his colleagues to model the changes in productivity over time for each of those species over time in different parts of the ocean. And what we're going to do is then use that as a platform to ask, well, what if you continue with status quo management and that sort of climate change occurs over time? What if you just change management today along the lines of the last 15 minutes of my talk? So if we just fix management today and climate change occurs along these lines, how much of a dent can we put in the negative, in the downside of climate change? How much does fixing management today fix the effects of climate change? And finally, suppose we could fully anticipate the consequences of climate change in fisheries and adapt institutions now in anticipation of those effects. How much additional benefit do we get from that? So we think of this as the economic value of adaptation. Of course, we can measure it in terms of biomass and food. I'm going to focus on how it changes livelihoods and profits in fisheries. Okay. So from the Halpern analysis, this gives you just a sense of how we expect those 700 or so species to be affected by climate change over time. And what I've plotted here is just a scaled version of the carrying capacity for each of those stocks. So some of these stocks are enormous and some are tiny. I've just plotted them all on the same plot here. And what you see is there's a huge amount of heterogeneity. A number of fish stocks in the world are actually likely to benefit from climate change. Those are all the ones that go up. But when they benefit, the benefits are fairly small. This is, from a production perspective. On the other hand, you can lose big time. You can lose 50, 60, 70% of your carrying capacity over the next 100 years for other species. I plotted the weighted average, where it's weighted by the size of the stock in red, and that has a slight decline to it. If you use that as a baseline and you say, okay, suppose that actually occurs for each of those stocks, and we're going to model out the potential of each of those stocks over time, we can ask, how much does just improving management today, just doing what the previous paper that I talked about earlier, how far does that go to mitigating the effects of climate change? Okay? And what we find is really quite striking. Just improving fishery management today in a way that we call naturally adaptive. That is, you lower fishing pressure when the biomass of fish goes down, you raise fishing pressure when the opposite happens. You aren't anticipating climate change, but you are recognizing that the world is dynamic, and sometimes the fish stock is low and you don't want to catch so many fish in that setting. If you do that, if you adapt institutions in that way, you can take a huge bite out of the effects of climate change, and the value of that kind of adaptation is on the order of 20 to 30% of the value of a fishery. The last result I want to show you is really the striking one, okay? And so here what we asked is, suppose you've already put those good institutions in place under the current climate. Now you can perfectly forecast the future climate and change institutions, change the way fisheries are managed to fully anticipate what the effects of climate change will be. How much additional benefit do you get? And the answer is not very much. If you adapt institutions correctly today, you get almost all of the benefit that you could get. And we think this is a very striking result and an important result because it suggests we don't have to have perfect knowledge of exactly what the effects of climate change will be in order to do something very productive and very worthwhile from an economic standpoint today. Thank you very much. I look forward to any questions you might have.
Thanks, Chris. The floor is open for your questions. Yes.
Hello, Neela Patel, and thank you for a very beautiful talk making it very clear how there's a financial benefit, a benefit to the ecosystem, and a benefit from food return for really the regional fisheries management model. And I'd like to understand, because the case is so compelling, what are the points of resistance to implementation globally? Is it a lack of knowledge? Is it that actually locally they aren't going to benefit financially? Anyway, we'd love to hear about that. Thank you.
Yeah, this is really a fantastic question, and we've studied this not just in the journals and in our theory, but actually been on the ground. In fact, we were recently in Indonesia, and Dr. Lubchenco was recently in China discussing some of these very issues with the governments there. I would say there are a number of important answers to your question, but the one I'd like to focus on is this issue of the timing to recovery. The way to recover fish stocks is to fish less now and recover those stocks. And even if I tell you that in 10 years, just trust me, you're going to be able to catch more later and you're going to be able to make more money later, there's still a 10-year period where you're potentially catching less, or let's say a 5-year period where you're catching less and then you start to ramp up. And that period of time has potentially enormous economic costs. Now, we've accounted for that in our projections and said, even taking the net present value of these economic effects, it's still worth it to recover the fisheries. But that's a tough pill to swallow for a lot of governments when they have starving fishermen on their hands who want to catch those fish. So one of the things we've been working on is a set of institutions that might be put in place that allow them to get over that valley of death, some people call it, so that downturn in catch for the promise of a much better future.
Yes.
Bob Wilson, Harvard-Smithsonian Center for Astrophysics. How do you go about measuring the fish stock these days? In the past, there was sort of a fishing effort versus catch. Is there something better now?
Well, apparently acoustic surveys are pretty good. But no, this is a great question, and this is really the first graph I showed. It gets at that issue. So there's a thing called a stock assessment. There's a field of fisheries science, and fisheries scientists figure out ways to use things like catch and effort and go and drag research trawls around the ocean, and from those try to back out what the underlying fish stock must be. That's, in a sense, the old school method, and it's still done, and it's still a good way to do it, but it costs $500,000 a pop. There's a whole series of new approaches called data-poor stock assessment approaches that make use of local ecological knowledge, that make use of trends in the size of fish, not just the rate of catch, and a bunch of other data like that that are readily available if you know how to extract the signals from them. Thank you.
Chris, I know from personal experience how challenging it is to support fishery reform. But one of the challenges really is providing the resources to make that transition. What ideas are out there today about how to enable a transition to a better place, understanding that there is a cost? The benefit is out there, but the cost is immediate.
Great question, and I think it goes back to that first question in many ways. Let me talk about two approaches. One is, in a sense, a private sector approach. Okay, so if you implement the kinds of reforms that I'm talking about, and some of which have worked quite well in this country and a number of other countries, you can give fishermen a financial stake in the future health of the fishery. And the basic way to do that is you make them a guaranteed owner in part of the fish stock in the future. So they have a right to continue to fish 10 years from now, not just today. That's not true for many parts of the world. It is true for many of the fisheries in the United States. The reason that helps fix the problem is that if I know that in 5 years or 7 years, I still will get to fish and I will get a certain fraction of the catch, then I have an incentive to try to restore that stock. And I have I might be willing to undertake a short-term loss because I know that I will be the beneficiary of the long-term gain. That's not true in a lot of fisheries in the world. Another approach that's getting a lot of attention is the idea of the finance sector actually helping get people over this hump, this valley of death that I mentioned. And there are a number of different approaches there, but essentially it amounts to paying fishermen to, for example, help collect scientific data during that downturn to help motivate the recovery, but also get them over that hump financially.
Thank you. Question here?
David Jablonski, University of Chicago. Halpern's work has emphasized that it's not just climate change, it's involved in the changes that are going on in the ocean. We heard that, in fact, in the introduction to this symposium. So have you factored in effects of ocean acidification and pollution, invasive species that are introducing diseases and predators and other enemies, and other sorts of pressures in addition to climate change that are quite possibly at least as important, maybe more?
Excellent question. Thank you very much. We have factored that in implicitly in the historical record because the most recent stock assessments account for to the extent that those things have already started to occur. But to the extent that they're likely to make dramatic shifts in the future, we have not gotten that far yet. But the work I mentioned on climate change is sort of, in a sense, the tip of the iceberg, pardon the pun, Fiamma, but the tip of the iceberg on starting to think about how those major changes in the future trajectory of ocean productivity could affect fisheries, but also how can we respond best to it.
Final question, Chris?
Chris Field, Carnegie Science. You spoke as if all of the fish stocks are functionally independent. How much do we need to worry about interdependencies where letting one recover means that they eat some other fishery?
Yeah. This is a huge issue, Chris. Thank you very much for that question. And I had one little bullet that you might have noticed on one of those slides on that, because this has become a huge part of our work going forward. Let me say two quick things. The first is that when a stock assessment is done, it implicitly asks what is the mortality, the natural mortality rate for that species out in the ocean. And so to the extent that there are predators eating that species, it's sort of implicitly factored in, not in an explicit way. But that's going to be fine if everything sort of stays the same. But if things change in the future, if you restore a predatory fish, for example, you might deplete the prey fish. And that has not been factored in yet. I had one little bullet on food web effects. Let me give you an anecdote. In China, remember China has these huge potential benefits. One of the hypotheses that's out there, and we think there might be some credibility to this, is that what China has done, so they've had very high sustained fish catches over time. One of the hypotheses is that they've fished out their predatory fish, and that has allowed the prey to explode. And so even though it may look like they're manipulating data or whatever they're doing to keep catches high, in fact what it is they just caught all the predators and basically made the ocean more productive, the China part of the ocean. So this hasn't been validated yet, but I think this is an example of the sort of phenomenon that you're referring to.
So we have one more person who's stepped up to the microphone. We'll do it very quickly.
Yes, Patrice Lyons. I come from the legal community. I'm an attorney here in D.C. And when you're talking about institutional frameworks, and the fisheries have a global aspect, in addition to the fisheries that might be under the jurisdiction of particular state governments. Are you envisaging sort of a law of the sea plus to actually institutionally control some of these? And it's a very, very difficult area.
It is indeed, and thank you for the question. I could stand here for, let's have lunch together because I'd love to chat about this, but I'll just say a quick note on that. So let me specifically talk about that with respect to climate change. One of the things that's happening with climate change is fish stocks tend to be migrating poleward. When fish stocks migrate, they intersect more exclusive economic zones, or at least different exclusive economic zones, and perhaps the high seas. This creates an institutional challenge, which I have not addressed so far I didn't address in the talk. So we're looking at new institutional frameworks. For example, in Europe, they're looking at transboundary ITQs, so ways to manage the stock in a shared way across different countries. That's just one example. And then on the high seas, you'd have a whole other set of institutions. So this has opened up, I think, a really interesting field of research that has, people really haven't tackled this yet. So we're just now getting started looking at that.
Thank you, Dr. Costello.
Thank you.
Appreciate it very much.